Welcome back to this video series of C++ programming. This is the lecture 24 of this video series, and today we are going to discuss about inheritance in C++ programming. It is a continuation of the previous lecture of inheritance. We'll today talk about few of the important points about the inheritance. Today we'll discuss about the protected members in the inheritance. The protected keyword is included in C++ to provide a greater flexibility in the inheritance mechanism. That means when you use the protected keyword, it provides a different meaning when you use the inheritance mechanism or derive one class from the another class. When a member of a class is derived as a protected, that member is not accessible by other non-member elements of the program. Access to protected member is the same as that access to private member. That is, it can be accessed only by the other members of its class. So that means if you create one class and if you create a protected member within that class, then those protected members can just be accessed by the public members of that class. So it is similar to accessing the protected members. They cannot be accessed outside the class. But exception to this is when protected member is inherited. In this case, the protected members differ substantially from the private one. That means now in this case, the protected members of the base class can be accessed through a derived class as well. So this is how the protected members works in the case of inheritance mechanism. We'll understand this protected members with help of these examples. First we'll see how we can access the protected members in the inheritance. So here I will create two classes. First one is a, let's call this as a base. Alright, I will create another class and we'll call this as a derived class. Now this class is derived from the space class here. So you have to specify some access here. So I'll specify the public. That means all the protected members of this base class will become a protected to this derived class, and all the public members will become a public to this derived class. That means now this A and B are now acting as protected members within this derived class. So these two members, I will change this as a private here, and we'll also change the name of these functions. Now inside this protected members A and B now become a protected for this base class. So that means those members can directly be accessed from the with the help of this public member functions. So now let's just change the name of this variable here. You can see if I try to assign some value to A, the compiler will consider this as a valid operation. So now it is saying this is A is referring, or it comes under scope of this base class. This is because it is a protected members of this base class, and since now we derived it, it becomes a protected of this derived class as well. Even with this public access specifier, it behaves the same. Now when you specify the public, now this protected members become a protected, and these public members become a public. If I change this as a protected here, now as we talked before, this all the private and the protected members of the base class will become a protected to this derived class. That means now this set and a display function of the base class cannot be accessed outside this derived class. So if we create one object of the derived class here D and try to access this set member function of this derived base class, now the compiler will show an error saying the function is inaccessible. So this function is visible but it is not accessible. The reason is since it is a protected access we have specified here, this all the public and protected members have become protected to this derived class. So that's the reason they are not able to access outside this derived class. And if you specify here a private, then again all the protected and public members will become a private to this derived class. So still they will be able to access this A and B, you should be able to access through this public member functions of the derived class. So this is how this access specifiers and protected members works in case of the inheritance mechanism. But this protected member plays important role when you are using the multiple inheritance. Let's understand how. So here I will create a one more class and we call this as a derived one, and we derive this class from the previously derived class, so that is this class. So now this derived class acting as a base class for this derived one. In this case here, let me change this to protected, or first we'll see with help of a public. So for both the this classes, the access is a public. So that means all these members, protected members, are protected to this derived class as well as this derived one class. Now in this case, since A and B are protected, they become protected for this derived class. So that's why they can be accessed from this public member functions. Similarly, this A and B public members of the base class will become protected from this derived one class, even though it is derived from this derived class. So this is how this multiple inheritance works. So all these members are automatically inherited by the classes or by the multiple derived classes. Even if you change this as a protected here, still the meaning of this I mean, since still this A and B protected member variable should be accessible by this both this derived classes, that is a derived and a derived one. So compiler is not showing any error; it is still able to access this a member variables from the base class. But if you specify here as private, and here also if you specify this as a private, so in this case what happens? Now when you specify the private access here, all the protected members and all the public members will become a private for this derived class. So once they become a private, they cannot be accessed outside this derived class. So when you, in this case, when you are deriving this class, derived one from this derived class, you cannot access this A and B member variables of the base classes as you do in this case. So here, if you try to access, your compiler will show the error showing this A is not accessible. The reason is simple as we talked. Since now here we have specified the private, the access is limited up to this class. So even if you specify here as a public, still you should not be able to access this A variable, because now this A variable, the scope of that A variable is restricted till this point after we specify this private access specifier. So this is how this access specifier and protected members works in case of a multiple inheritance. So we saw these two examples of using the protected members. It is also possible for a derived class to inherit two or more base classes. In this example, if you create two base classes, so base 1 and a base 2 assume, then this derived class can inherit all these properties of the base 1 and a base 2 class. So it can have all the members of the base 1 and a base 2 classes. So this is how we can have the multiple this is how we can inherit two or more base classes in the derived classes. So this is all from this video. I hope now you have understood the importance of these protected members in the case of inheritance mechanism in C++. So thanks for watching this video and see you for the upcoming video.